What's up, guys? We're going to look at the altitude and medians of triangles. Last lesson, we looked at the mid segment. So this is two other line segments that are what we would consider to be special segments. The altitude, by definition, is any line segment drawn from the vertex of a triangle that is drawn down perpendicular to the other side, opposite side. So as you can see here, you can see our altitude. So it doesn't always have to be, the altitude doesn't always have to be inside the triangle. So that's what this first triangle here is showing you, is that the altitude can be drawn sometimes outside, with that opposite side being extended out. So the orthocenter is the intersection point of all the altitudes. So if I were to draw the orthocenter, I would draw a line that is going to go from, so now let's look at the median. So by definition, this is a line segment drawn from one vertex of the triangle that will intersect the opposite side at the midpoint. So you can see that the two sides right here at the bottom, those are going to be the same distance. So that length are going to be basically doubled. So the centroid is going to be what we call the center of all of those, or is going to be the intersection of all those medians. And then also something else about the centroid is that the centroid is twice the distance from the vertex as it is from the centroid to that opposite side. And so we'll take a look and see what that looks like. But if you could kind of break it up, this is going to be twice as long as this piece here. So if I were to draw all of these, just to kind of see what that looks like. So halfway in between, maybe here, and then probably about right here. And so this would be considered to be the centroid, okay? So this right here, so from this point to the centroid, that is going to be twice from the centroid to this blue dot. So out there towards to where it intersects that side at that midpoint, okay? So if this was X, this would be 2X. It's going to be twice whatever that is. So if X is 5, so then from the blue point to the centroid, that would be 5. And then from the centroid to that top vertex point, that would be twice or 2 times 5, twice of that, which would be 10. So that's kind of sort of what we're looking at when we look at centroid. And that's what we will work with that a little bit here in the next examples. So we are going to name the orthocenter. So the orthocenter, remember, is the intersection of all the altitudes. The altitudes make a 90-degree angle from the opposite vertex. So you can see here that AH is an altitude, and then CE is an altitude, and then BF is an altitude. So those all intersect here at X. So X is the orthocenter. So it's just identifying what that means. So there's some other intersection points like CD. That is going to be that's a line there, but that does not an altitude. So if it does not the altitude, even though if it goes from one side of the triangle to the other, wherever those points cross, it's not going to be included in that orthocenter. Okay, so we have that P is the centroid of triangle MNO. And so MP is 14x plus 8y. And so we're going to write expressions. And so it's going to end up not being a nice, pretty number. So it's going to be left in an expression form to represent PR and MR. So we're looking at PR, okay? And then we're looking at this whole distance from M to R. Okay, so I think it's easier to find PR first. So if we know that from M to P, and it's going to be kind of hard to see this, but this distance here is the 14x plus 8y. All right. So to find PR, that is going to be, since this piece here is twice what PR is, but I don't know PR. So I know that that's going to be half of 14x plus 8y. And then make that y a little better. So then distributing that to both of those coefficients there, I'm going to have 7x plus 4y. That is the expression that would represent PR. If I had a value for x and y, I could go ahead and plug it in, but I don't have a value, so I'm just leaving it there. So that's part of it. Now I need to find MR. So something that we haven't talked about much is the segment addition theorem. So that is where if I have a piece of a line segment, so if I have this line segment here and it's cut up, and I know that this line segment is A distance, and I know that this line segment is B distance, then the whole thing from this point to this point would end up being A plus B. Okay, so whatever the A is plus whatever the B is. So that kind of seems kind of common sensey, but that's just something that we're going to apply that to finding what MR is. So I know that MR is going to be MP, which we know, plus PR, which we know because we just found it out. So MP is going to be 14x plus 8y, and PR I just found to be 7x plus 4y. And so now that's going to be whatever line segment MR is, excuse me. And so then I'll just add the coefficients that have the same variable. So that I'm going to have 21x plus 12y. And that's what I have there. All right, so this last example is pretty involved because we're going to be looking at 3 different pieces here. So if I know that CW, so this is the we're going to say this is all medians, okay? So if I know that CW is 15, so that whole distance is 15 right there. So I'm going to go ahead and draw it out here. I'm going to go from, I'll do W and C kind of backwards like they have it, okay? And I have X somewhere about right here. If I know this whole thing is 15, okay? So I'm just taking this little piece there that we have, and I am going to write it out here with this little line segment. Well, I'm trying to find out what CX is, and I'm trying to figure out what XW is. So when I don't know something, I just represent it with the letter X or Y or just a variable that I don't know. So I'm going to use the letter A since I have a capital X here. So I don't know this distance there. And I don't know the distance from X to W, but I do know that since this is the centroid, that this is going to be twice the distance from here, okay, which I know is A. So I would have 15 is going to be equal to 2A plus A. And then those get together and make 3A because they have the same variable raised to the same power. So then I'll solve for A and I get 5 is equal to A. Now that does not tell me that tells me what CX is, but I also have to figure out what XW is. So CX is just whatever A is, which is 5. And then XW is twice of that, so 2 times 5, which makes 10. So that's that first part. Now let's look at BX. We know BX and we're trying to find BY and XY. So BX, here we go. Let's go ahead and draw this out. I'm going to try to draw it outside that triangle because it's kind of hard to see. And so I know that B to X is 8, okay? I also know that that is twice the distance of what XY is. So from X to Y, I know that's going to be half of 8, which ends up being 4. Okay. And now I need to figure out what from B to Y ends up being. So I'm going to use my angle addition theorem. And so I know that BY is going to be BX plus XY. So BX is 8 and XY is 4. And so that's what BY is going to be. So BY is 12. And I also needed to find XY, which I had already done based on the fact that I know that the centroid from the vertex to the centroid is twice the distance from the centroid to the opposite side. Okay, and then I have XZ is 3. I need to find AX and AZ. So I am going to draw it. So this is A, and this is X, and this is Z. And so I know AX is 3. And so I know, excuse me, no, not AX is 3. XZ is 3, excuse me. And I know that AX, since that's going from the vertex to the centroid, is twice what going from the centroid to the opposite side is. So I know that this is going to be 2 times 3, which ends up being 6. I also know that from A to Z has to be those two added together. So I have AZ is going to be AX plus XZ. So A to X is, we figured it out to be twice of what the bottom one is, which is 3, plus 3. So AZ is going to be 9. And I figured out what AZ, AX was based on what we know the relationship between the centroid and the vertex and the opposite side. And so we figured out that to be 6. So remember, there's a lot of vocab that we have going on here. There's a lot of vocab. We have the centroid, and then we have the orthocenter, which that is where the orthocenter, we didn't work a lot with that. That is just where the altitudes are going to intersect. Remember that altitudes are where there's a line drawn from the vertex to the opposite side that makes a right angle. And then the median is the centroid is where the medians intersect. The median is where it's drawn from the vertex to the opposite side, and it cuts the opposite side in half. Basically, it's the midpoint. And so that's what we're looking at here when you are looking at the medians and the altitudes of triangles.